Well, hello everyone. Welcome to our presentation of our EGR 2800 sophomore design project, Arduino Pong. My name is Nick Knotts. I did this project with Ian Smith, Maryam Supi, Josh Fire, and Mason Zielaskowski. So this is my contribution to the project. First of all, we had this crazy idea. I believe it was Mason in the first place who came up with an idea to do a game. And we kind of morphed it from what initially we thought would be a good idea up to what we settled upon, which was Arduino Pong, which is a game that everybody can play, regardless of the walks of life they come from. If you have young children or older grandparents, perhaps, you may know that trying to find a game to where everybody can enjoy it is sometimes difficult, and we also wanted to do something that was fun to create. So team building is a very difficult thing that I worked very hard on throughout this project. We didn't know each other walking into all this, and we had to build a team and make it work around our very, very busy schedules, which is never easy. But we managed to bond together as a team to make this idea a true reality. I also programmed the catapult. I wrote a program that was both simple, yet did the job, and so we wanted to keep the user input as low as possible because you don't want to overwhelm the user with, all these inputs that they don't understand. So we kept it as simple as one joystick to work the entire game, including the power of the catapult and the firing of the catapult. Building and wiring, so I assisted in the building of the table and the configuration of the catapult, and I also wired the catapult system and the joystick. We ran firing tests at Ian's house to ensure we had the optimal firing distance for the catapult, which was somewhat difficult because we actually built a catapult that was too powerful in the first place. We were able to fire a ping pong ball at 20 feet, while our game really only rests on 4 feet of area we have. So it was certainly challenging to calibrate that to be perfect. And that was something we worked on heavily. It took us about an hour and a half to calibrate it. But once we had it, it was very rewarding. And we were able to work that in with the motor and the actual joystick itself to fire the catapult properly.
Hi, my name is Josh, and my contributions to the project were the electrical components and assistance with the assembly of the game. The parts required for our electrical components were 3 FSRs, an LCD display, 3 LEDs, 3 10K resistors, 6 220 ohm resistors, 1 10K potentiometer, and 3 push buttons. Our first component was FSR sensors connected to LEDs. The idea behind this was to use an FSR to detect the force of a ball coming into a basket and to turn on an LED to show that a basket was made. The components used were a breadboard, 3 FSRs, 3 LEDs, 6 total resistors, and 1 Arduino board. On the left, you have a picture of what the FSR looked like inside the basket, and on the right, you have the wiring done to make it all work. Our second component was a simple LCD scorekeeper. The idea behind this is to display the score on an LCD so that the player does not have to memorize their score or write it down on a piece of paper. Our components used were a breadboard, LCD display, 3 push buttons, 1 10K potentiometer, and 3 220 ohm resistors. Here's a picture of what the LCD scorekeeper looked like once assembled. The challenges we ran into in the making of our electrical components were that the force of the ball on the FSR sensors had to be in an exact spot. Our second challenge was that the wiring connections needed to be taped because if they came undone, the system would not work. And the third and final challenge were that some of the required parts were not in our kits.
Hey, this is Ian. At the beginning of the project, my main contribution was designing the mechanical subsystems of the game. And this involved me making hand-drawn schematics and diagrams of the catapult, of how we would turn the catapult, and of the game itself. Now, I also assisted in the execution of the assembly. I helped cut the wood, figure out how it was all going to be put together, figure out the dimensions of the project, and I also assisted in the wiring of the electrical systems onto the finished project itself. And this involved putting together the wiring for the catapult with the servo and the motor that control it. This involved the wiring for the score goals, where there are sensors inside that triggered LEDs when a goal would be made. And this also had a contribution to helping just mount the scoreboard that kept the score for the game. And after assembly was completed, as one might imagine, there was some complications with the code not working the first try. So afterward, I had to edit the code a little bit to get it to be a bit better and perform how we wanted it. And that was my contribution.
For the CATIA drawing, I sketched 3 different sketches. This is the first one. It's a 3D model using mechanical parts design. First, smaller and simple components are modeled in part design and then assembled in assembly design. Various operations such as sketching holes, pockets, groove, and solid combine are used. This drawing has 3 parts only: base, arm, and frame. The second drawing has more detailed parts such as base, arm, rope support, and gears. The third and final sketch I added only the big table, and the other sketch is the same as this one. Several challenges were faced in modeling the sketches. Some parts were very complex, such as the gears. These parts were modeled individually and then assembly. Another major issue was the lack of detailed dimensions, which was solved by approximating to make the drawing look alike to the original.
Hello, my name is Mason, and the first thing that I did to help with our project was in the initial planning phase. I think it was Nick that mentioned that it was my idea for us to build a game. I got the idea from this, and I thought we could do like a physical game that we could control with the Arduino. I thought that would be really fun and something that we could get excited about. The next thing that I did to help in our project was with the software subsystems. I laid out all of how the software was going to work and how each of the components are going to have to interact and be controlled via the Arduino. And then I also laid out some of the base code for the other guys to implement and finish up, as well as do a little bit of play testing, of course. I also was in charge of taking the lead of the video and communicating with everybody on getting all of their work together so that we could all be on the same timeline.